is Dr. Brittany Beck. I'm an assistant professor of teacher education at California State University, Bakersfield, and the director of the Citizen Scientist Project. I'll try to do an abridged version of this so we can get you out close to 5 as possible. True to its name, the Citizen Science Project is designed to build capacity for citizen science in K-12 and teacher education. We work predominantly with pre-service teachers and their mentor teachers, but we also work with in-service teachers in tons of different capacities as well. But for our purposes today, we're going to focus on pre-service teacher education. Now, citizen science is a relatively new idea in the field of education. Only in the past couple of decades has there been a resurgence and a naming of it. Citizen science, broadly defined, is research that's performed collaboratively between formally trained scientists and curious members of the public like you and your students. Our partners at Nat Geo and SciStarter say that citizen science can happen anywhere and a citizen scientist can be anyone. And the beauty of citizen science, much like everyone has spoke to today regarding addressing real-world issues, citizen science is actually real data that real students collect and that real scientists use to make better informed decisions at the classroom, school, and community level. But a different way to operationalize citizen science that might be more familiar in the current landscape of standards in California is enabling teachers and students to apply C-STEAM competencies, with the C standing for computer science, to identify and address issues of community concern, to do so in partnership between teachers, students, scientists, and community agencies. And then most germane to our purpose today is using citizen science and data science to democratize science by including more diverse voices in question posing, data collection, data analysis, data visualization, and data-informed advocacy. Like Dr. Uy said, this work, this blending of data science and citizen science is rooted in what was the 21 revisions, I think maybe now the 22 revisions, to the California Mathematics Framework. And specifically, Chapter 5 is focused on data science. Now, in that Chapter 5, like early on, you'll read the call for creating data literate students and communities. The fact that data drives students' lives, whether they see it around them or not, and that making sense of data, being able to identify data as misleading and using data to make decisions are important for their role as global citizens. And I think as we've all navigated this global pandemic, the importance of scientific literacy and data literacy in terms of making informed decisions for ourselves and our health and the health of our communities is just one vibrant example of why this is so important, and how misleading data could be, depending on your level of data literacy and scientific literacy. I want to share a quick teacher reflection. So as part of my science methods course, they do a whole set of modules related to citizen science. And one of those modules is connecting data science and citizen science together. And so I've actually just pulled a little clip from an assignment that one of my teachers submitted. Her name is Maho, and she's preparing to teach elementary school. And so I thought it would be best to use her words in terms of how she understands the connection between data science and citizen science. So with that, this is, the teacher's first impressions of reading Chapter 5 of the data science chapter and the new revisions to the California Mathematics Frameworks, learning about citizen science and trying to grapple with those two and put them together. And so as part of this assignment, they were also required to choose a particular citizen science project. In this case, she chose the marine debris tracker, which is a bit of a misnomer. They're trying to change the name right now to just debris tracker, because you don't necessarily have to be near a marine environment. You can track debris anywhere. And this, in part funded by our partners at National Geographic and NOAA, you can download it. It's a free app. You can download it on your phone, on iPads. You can just participate in their the online version of their work, but you go outside in your community. If you see a piece of trash, you can take a picture, you can categorize it, you can upload it to a database. And then the app automatically gives you different types of data visualizations that you can use in terms of the type of data that you collect. It offers some geospatial data analysis in terms of like what was your route and what did you collect there. But there's also the ability for you to see data that's collected all over the world. And so this is data that's been collected over the past, I think, month, all over the world using this debris tracker app. And so this teacher also, as part of this module, so once students collected the data, so they learned about the issue, they collected the data, and then this is her talking about how they use RoboBlockly to visualize the data. And ultimately, one of the other things we emphasize is to tell the story of the data. And then I'm going to pause here. I have a student artifact from our last Girls in Robotics Leadership Camp, in which students use the Marine Debris Tracker app to track debris around their school, and then use that to inform the storytelling they did with the link bots. But I'll share that only if we have time at the end, and I can send it to anyone who wants it too. All right, thank you. And then here's my contact information. I'll put that in the chat as well. All right, Jesus Esquivel, you're up.
Thank you, Dr. Beck. I appreciate you setting the stage, because I do work with Dr. Brittany Beck at Cal State University, Bakersfield. We work together on the Citizen Scientist Project, and I just want to quickly just share the initiatives that I've kind of taken under. I teach the math methods coursework for our credentialing program at Bakersfield. So I want to share how I have integrated the C-STEM into the elementary math methods course, which is primarily right now we're working in K-5. So the students that I'm placing in schools are mostly in K-5, and in this particular semester they're in the 3-5 span. So I've focused purely on like that grade span 3 through 5. So I wanted to kind of just share how I have approached this C-STEM integration, and kind of show how the Citizen Scientist Project is also being mindful of the data science integration within the C-STEM integration. So as you can see, I've kind of highlighted the math methods course, and this would be like a timeline of the entire span. And I've kind of approached this in a linear side. I want to share with you all the framework that I use for teaching programming concepts, because that's a big idea, especially with new learners. Like, these aren't teachers that have opted into like a computer science degree. These are elementary pre-service teachers that are multiple subject degrees with very little or zero experience and background in computer science. And that would also be the same with math. Most of them approach me and say they have a math phobia before the course even starts. So this is the group that I'm working with, and it's important that we can set up scaffolds that work for them, that help them have opportunities to succeed in this area, to hopefully change perceptions. But through this work, we use what I call the Use, Modify, Create framework. It's research based, and there's a group of people, and I can share some resources with that. It's at the end of my slides. But through this process, the C-STEM Center has offered they've created a set of programs and like coding sequences that we're training to use for this residents and these credentialing students. And what I'm trying to do is take them through these and work with them in these instances where we do 2-hour blocks, and we've spent 3 sequences already on there. We're continually working on that right now currently. But at the end of this sequence, what we're going to do at the end of this semester, they actually get a C-STEM certification. And it's kind of nice just to, as they're going out into the field and applying for the jobs, to say that they have some experience with C-STEM. So that's a nice piece of this. So that's kind of where we start with. And I wanted just to quickly share with you this thinking on how we introduce and approach coding in particular with our students. And a lot of the programs that are already built on the C-STEM Center, on the Robo Blockley Center website, use this similar framework. And so I think it's a perfect launch point for everyone to kind of see how it is, but also to kind of make mention that this is the science that goes behind it. But really what we're talking about here is like giving them a program that already exists, that already functions, and allowing them to explore it by changing parameters, by changing some of the inputs, some of the variable settings, just to see how that program works. Rather than giving them the blank slate and saying, hey, build this, right? So this is just quickly, I wanted to mention it to you, and I'll make this public so you can actually look at these slides later if you have an interest in seeing more about it. But in the interest of time, this is kind of the iteration or the process that my students, when they started, I gave them, a set, like this is after 2 hours of coding practice. They had understood the basics of like how to make a robot move forward and backwards and do some different things with line tracing and changing the speeds. So that was their first assignment. After the first day, the first sequence of learning, what I had them do was just take that original template and modify it, make it their own. And then after the second sequence, we added some additional things like the blinking of the lights, voice, the changing of the speed of the voice, and a lot of those different things. And you'll see that this is how like they took that original program and then they've modified it again. And so each time that we meet and we have these learning sequences, they just continually revisit this program and they're adding to it. And it really does give them a sense of like they're building on something a week and week, and it's not disjointed in the learning. So we really have taken on to this use, modify, create, and I just wanted to share it with you because I'm having some success with it, especially with new teachers, people that are outside of the C-STEM and the field of computer programming, especially are grateful for that work. How do I connect this to data science? How am I using data science in my math methods coursework to introduce this idea of C-STEM with data science thinking? So I've, like Dr. Beck had mentioned, she used the marine tracker. Well, I've used what's called the iNaturalist program, and what it is just it's a cataloger. You can use your cell phone to take pictures, and you can upload observations of different flora or fauna that are out in the field that you find out in the field. And we use that as a database for scientists use it as a database to actually, to see if there's populations that are growing or shrinking. So they can use it for all sorts of different animals and so on. But to kind of give you just a quick idea, when I say data science in the K-5 grade span, what I really am talking about is data sense. And I hope that sticks with you all, especially my teachers that are out there. Data science is data sense. What I mean is we need to give our students an opportunity, and when I say students, I'm also talking about my teachers of K-5, an opportunity to understand or reconceptualize what data means. It's not just about numbers. There's a story behind those numbers. There's information behind those numbers, and we really want them to get a sense and make that shift in thinking. So when I say data science in the K-5 span specifically, I'm really talking about data sense. And so I want to talk about that, and I'm always returning to this idea of like, what stories does that data tell us? What is that data telling us? And so we're using that information. And here's an example of what iNaturalist does. I gave my elementary methods students, my pre-service students, an opportunity to go outside and to tag different flora, fauna, whatever they were using, whatever they were looking at or interested in. But then they upload those onto this iNaturalist website, and instantly they are given a chart that gives them two sets of variables. So like they're looking at a time, the amount of observations over a history of time. And then it also has a lot of extra information. And I encourage you to check out iNaturalist because it has a lot of great opportunities for data science entry points. But I want to also mention this one last piece because everything that's uploaded onto iNaturalist really has to be like they have to manage that data, and these are like some of like the pivotal ideas of like when I said data science is data sense, what I'm really saying is how are they managing that data? Do they understand the data they're using? Is it a solid source of data? And like what steps are they taking to think about that data? So they actually, when they upload, there's this other people have from this iNaturalist community have to vote on it in order for it to reach a certain grade, like research grade quality means that they've reached, all of these criteria have been marked off. So students have to be mindful of the observations that they're uploading. And I just love this idea because they post and then they can come back after 2-3 days and they can see that, hey, someone's actually reviewed your data point and they're saying, hey, there's a couple of things on here that you didn't include, like you didn't put the date or you didn't put the, specify the location. Sometimes they'll try to upload a picture from a zoo or something, but that organism doesn't exist in the wild. And so they'll make these little marks. You'll see a little red mark here. And this is just a great way for them to start to make sense of data and to give it, like, to really kind of understand like the connections to the data. In the interest of time, what I wanted to do was just also mention, if you're looking for entry points into data science, I will put this onto the slides and add this into it, but these are some great resources that I've used to kind of approach this idea of data science in math. So thank you for your time, and I'm going to pass it on to our next participant. Thank you. You're on mute. Okay.
Yeah, I guess that would be me, Timothy Keys. Okay, I'm going to try to get this done really, really quickly. So I am a 5th grade teacher. You can see I'm in my classroom, and I'm going to talk a little bit about the foundations of data analysis in elementary school. One of the things, I love teaching elementary school because you get at the foundations. I like philosophical foundational stuff. Just a little bit of trivia. There are actually 4 ways to pronounce data. The top 2 are from Britain, the bottom 2 are from America. And then there's a big debate amongst philosophers. Does math really exist? Is it artificial or real? We know 1 + 1 is 2. Everybody likes that, right? But it's 10 in base 2. It is 2 in base 3, but if you add 2 + 2 in base 3, you get 11. If you go back to ancient Babylonia, they use sexagesimal, which is a base 60. So is this artificial? Is it real? What do we know? That things in the universe do exist in relationship to each other in ways that can be quantified with mathematical systems. And these relationships, oh, hold on 1 second. There we go. These relationships, they exist as data. And so this is the idea of what we're looking at, getting the kids to understand that data is the way things exist in the universe in relationship to each other. This can be quantified. And this kind of quantification can be communicated through mathematics all across the world. And it's useful, but a lot of mathematicians find the data relationships beautiful as well. And so there's a certain amount of art to the math that I like. If you go into the framework, right away, driver investigation 1, making sense of the world. This is what we're talking about, how things exist in mathematical relationships to each other. And this will help us predict what can happen. And in grades 3 through 5, where I am, we're refining measurements, and we're understanding that data has a lot of variability, a lot of variables. And all of these things I teach through my robotics program. So I have a very simple competition that I do with my class. We're in the middle of it right now. The blue there, that's a link bot, and there's a field. And it's going to push a little cube, I use a Unifix cube, across over the edge of the top of the rectangle. Now the competition is to get it as close to the edge as possible without it going over. And so the kids, we actually get really accurate. We've had kids get to within a ½ millimeter of that line, and these are like 5th graders. Now, what's the data? As I said, we are in the middle of the competition. I have certain criteria. So you see some of the trials and the runs get a no score because they weren't able to match the criteria. And you can see that I just put this up as a spreadsheet. And what it does is, because it's a competition, the kids start to look at it. You don't get anything unless the kids start paying attention. And they say, oh, who's winning? The snakes are winning right now because they're within 3 millimeters of that line. And you can actually chart this data. Now, some of the debates that we're going to have is, should we average it? What about those no scores? Are they going to be 0? If they're 0, that's really going to change the averages. I had to change those no scores to 0 just to chart the data here. And you can see here I have my groups. They're all named by our local animals. And you can see where they're at. And what they're trying to look at are the non-zero numbers. The zeros are, of course, the no scores. And you could see that the snakes here were doing really poorly, and then they got a nice low score of 3. You can see some teams are improving, their scores are getting smaller and smaller. Some teams, you know, they're having trouble. And this is what's great about looking at data and determining data.